So in the previous video we looked at the equation of state. PV is equal to mu RT, pressure, volume, number of moles, the universal gas constant and temperature T. In this video we will focus our attention on the universal gas constant R. First, what we'll do is we'll try to find out the unit of R. So R will be, as you can see, PV is equal to mu T. So let us take the units of all these terms and find out what will be the unit of R. So pressure is Newton per meter square because it's Pascal. So I can write down Newton per meter square. Volume is meter cube. Moles is just number, so it will not have any specific unit. Temperature, this temperature, so I can write Kelvin as the temperature. So, and the unit of this is number of moles. I'll simply write number of moles or moles is equal to, the unit would be meter sphere. I get Newton, meter, Kelvin, mole. And Newton meter we know is joule. So joule per mole Kelvin. And I can write this as joule per mole per Kelvin. So this is the unit of the universal gas constant R, joule per mole per Kelvin. And this is the SI unit of universal gas constant. If you just look at the units, you can also define universal gas constant as work done by the gas or on the gas. It could be either of them. Work done by the gas per unit mole of the gas per unit temperature change. So this could be a definition of universal gas constant. It's basically work done by the gas or on the gas per unit mole, per unit temperature, increase or decrease. So this is the unit of R. Let us try to get an idea about the value of R. Right? So I'll assume, or for STP, standard temperature and pressure conditions, I will put those values over here. Temperature will be 0 degrees Celsius, that is 273 Kelvin. Right? Pressure will be 1.01 into 10 raised to 5 Newton per meter square. And the volume of one mole of gas in this condition is 22.4 liters. Based on Avogadro's hypothesis, that will be 22.4 into 10 raised to minus 3 meter cube. So if these are the conditions, I can put those values over here and then we can find out the value of R. Right? For one, of course these are for 1 mole of gas. For 1 mole of gas, the volume is 22.5 liters at STP conditions, and this is based on Avogadro's hypothesis. Therefore, I can put the values over here. Pressure is 1.01 into 10 raised to 5 Newton per meter square into volume is 22.4 into 10 raised to minus 3. Right? Number of moles will be 1 and temperature is 273 Kelvin. And if I do a calculation of this, to save time, I'm not showing the actual calculation. You'll get 8.31, and that would be joule per mole per Kelvin. So this is the value of the universal gas constant, 8.31 joule per mole per Kelvin. If you want the values in calories, you will have 8.31 divided by 4.2, you get calorie per mole per Kelvin. Right? So two things we have done in this video. One is we have looked at the unit of the universal gas constant, and we have obtained R, value of R for 1 mole of gas. And as I said earlier, this value will remain constant because it remains constant for 1 mole of gas, and whenever we take 1 mole of gas, R is going to remain constant. And so that's why known as the universal gas constant. As we go ahead in thermodynamics, we will now look at the equation for pressure of an ideal gas, right? And please remember that we'll be looking only at ideal gases. So all the equations that we have got so far, that we'll be using those equations with the assumption that we are studying an ideal or perfect gas. Thank you.